great to be with you. I'm so happy to be back at International Passive House Open Days. Thank you, Carl and Aoife, for all that you're doing. It's so great to see all the projects around the world and so much activity going on. It's really, that's the key to it, is learning from each other and what we're doing around the world and sharing that knowledge. And so the International Passive House Days is such a great event, as was mentioned, happening twice a year. And it is so important because many people, when they learn about Passive House, you know, can be exposed to the concepts, can be exposed to the data, performance data, cost data, and still not be moved by it, as impressive as it might be. But so often when somebody comes into a Passive House and experiences it, they get it immediately, and they get it in a way that they never could without stepping into a Passive House. Now, today we're in one under construction, which is a special treat. We're not getting the performance out of it quite yet. It's a little chilly in here this afternoon, but it's a great way to learn from folks who are doing it. I hope everybody, wherever you may be, can take advantage of one of the open houses. It really is the most effective way of getting people on board and convinced about Passive House. So with that, I'd very much like to hand it over to the team here and get on with the tour.
Thank you, Ken.
Hey, Zach.
Michael.
Am I next now? Or you want this?
You are. Welcome everybody to, or please welcome Michael Ingui, founder of Passive House Accelerator and principal at Baxt Ingui.
Thanks. And woohoo! All right, so a couple of things.
Studio audience. Let's go. Let's hear it for Mike.
And Kevin Brennan. So thanks for coming, and thanks for coming. So this is kind of fun because we're going to do both in person and kind of live on the accelerator walkthrough of the house. I'd love to thank the R. Sutton team. Come on, guys, at least wave your hands so that everybody knows who you are. So I will say this, the job site, when you walk through right now, it's going to look really clean and really good. I can tell you, I come on a lot of off-site days. I very often come when there are no meetings, and it always looks good. I mean, they are like the perfect contractor to be doing their first passive project, which is what this is. And they're already doing good work. They're already clean. They're already neat. They like building. So it's been really good. They're working with Kevin Brennan, who's going to be talking with us in a few minutes. And then the Baxt Ingui team, yeah. and then the Baxt Ingui team, you've got Amy Failla, who's going to be speaking in a minute, Joey, Ashley, and we've got a really good crew. We are working with Building Type as our Passive House consultant. That's also great. So it's kind of like the dream team. We've got Kevin, Building Type, R. Sutton, Amy and Joey and Ashley. So just a little bit of an introduction to Baxt Ingui. We do a lot of Passive House projects. A lot of them, although we're doing one upstate, we're going to do one out in Long Island now. They won't be historic masonry retrofits. A lot of them are. This is a firehouse that was decommissioned, used as a religious facility, and then now being turned into residential with a community facility. It's not historic, but we're treating it like it is. It's in a historic district, but it's really beautiful. It's got a lot of great details, and Amy will get into that. We have a repeatable approach to doing passive houses. Our first one wasn't great. I mean, it was great. It certified, clients happy. It's actually LEED Platinum as well. But it wasn't great in that it took us too long, 3, 4, 5 months too long. And so we had a client who was really into it. But we definitely knew at that point, and as did that client, who kind of helped us, that we needed a repeatable approach. And what's great about Amy doing this walkthrough is her project, which was a house on Garden Place, one of the first houses in a landmark district to be certified. Amy and the team really helped create that repeatable approach that we're going to be going through today of kind of how we handle things, what we do, how we do it. And then right after that, Amy will kind of describe it in the details. Kevin's going to go through it in person and give us a little bit of a demonstration, and we'll walk through so everybody won't get bored just standing here. So with that, Amy Failla.
Thanks. Okay, I'll try to keep this steady. So going to stand up here just so I can point. So if you need to come forward, but so as Mike said, and thank you for the introduction, and thanks for coming, everyone. This was a firehouse built in the 1880s, and engine 16 company occupied it until like 1970, until they outgrew the building, and then it went up for sale, and a religious facility took over, and they were here until our client purchased it a few years ago. And so there were a lot of really great firehouse details still in the building, but the building had been kind of left in disrepair for quite some time. So we had really great stuff that we wanted to keep, but it was, it needed really to be gutted anyway, and was a perfect opportunity to do a passive house. And our client came to us asking for a passive house, which was really great as well. That our clients are coming to us, he can come down, educated, and we're seeing that our clients are just getting more educated, which is really nice. And so that's how the marriage started, and we've been working with them for a long time now. And we want to thank them for their participation and their commitment, because they're the ones making it happen, really. So so the building, we were limited on our zoning and floor area for code. So we basically we're maximizing out the envelope, and we are putting as many apartments in the building as we possibly could, while also fitting a community facility. So it's a mixed use. We've got the community facility on the first floor in the cellar. We have an apartment, 2 apartments on the second floor, a third apartment on the front that's a duplex, and then a 4th apartment that's actually a triplex. And we're actually adding this 5th floor with a roof, and we're adding a roof bulkhead. And then within the original building, which is this area here, we are, like I said, maximizing our floor area by kind of utilizing the really awesome ceiling heights that we had in this building, and adding mezzanines and storage lofts where we can. And then on this floor where we're standing, we are standing on the original stair that was here in the firehouse. We actually moved this. We took it down, had to do masonry repairs and the Viscon and air sealing, and then we put it back. So this will be the building entry and lobby. So this will be sort of like the first thing you see. And like I said, we're trying to honor the firehouse history everywhere where we can. And we're just to talk a little bit about some of the other details that we were able to reclaim. Had a really great tin ceiling on multiple levels that we reclaimed, firehouse hooks, really great like interior old windows that we'll be able to use on the interior, great railings and joists, flooring. Just the building bones were really, really good. So we're using everything that we can. And we actually, I don't know if you can pan around to the floor structure. You can see we did have to add steel and new joists in certain areas, but we actually kept or relocated existing joists as well, because the joists are just, like I said, massive. They built this building really well. It was not a developer building at the time. Yeah, come on down. So I'm gonna, on that note, actually introduce the team, and we're gonna start our walkthrough, and we'll see the details as we go down. We're gonna go down, and then we'll work our way back up. So Kevin Brennan is our air sealing and insulation installer and expert, and overall just resource for the tricky details, which we're constantly debating. And then R. Sutton is here as well, and they can chime in as questions come up. And then we encourage everyone to ask questions and make this as interactive as we can, and we can bring over the phone and the microphone. So on that note, yeah, let's go down and talk about the cellar slab. And
I'll just take a moment to remind everyone that as we're going through the tour, feel free to ask questions, and we'll do our best to integrate that into the presentation as well. And in chat, I just shared a link to a PDF that has a bunch of cool images of this project, including some of the ones that Amy was just showing. Okay, enough for me.
We might lose.
Yeah, we shouldn't go too far back. We'll lose it if we go back. So let's
Okay.
stay here. We can mute. I'll try my mic.
Oh, perfect.
Hey, what's up, guys? Can you hear me?
Yes.
Sounds good. No echo. All right, cool. So I'm Kevin Brennan with Brennan Insulation and Airtightness. I feel like I'm in a very small comedy club. All right, so I'm going to take advantage of this. Normally I'm in the basement when I tell my jokes, but thank RS Sutton, the Baxt Ingui team. It's been a great journey over here to work with Mike and the rest of the dedicated team at Baxt Ingui on multiple projects, and then to take the RS Sutton team as students in the Passive House tradesperson, develop a rapport, and be like, hey, we get along. Let's you guys speak my same language. We go to work, we have fun, we do great work, and we take pride in what we do, and it's a good work environment. So we're happy to work on it. I couldn't do my work without the guys that work with me, Timmy and Mike. They're the ones, putting on the air barriers, slinging the tape and everything like that. So it's great to have them as a part of the team. And it's an honor to work on such a great project like this, because it's an exemplary project for the city, in my opinion, because there are many firehouses like this that could be renovated to this standard without a lot of reach. My daytime job, I'm a New York City fireman, and there are multiple firehouses throughout the city that get renovated, their apparatus floor redone, and this could be the example that could set the tone for those apparatus floor replacements, because it's not that far different than what's happening at other 224 other engines that are happening in Brooklyn around the city. So I'm taking pride. Managing the details is really what happens. So we're starting with the basement and the great pictures on the wall. We'll start out with keeping the cellars dry, and we needed a vapor barrier that did two birds at one stone, and that is a vapor barrier that gives us a little bit of a drainage plane. It's a dimple mat, and then making sure it fits to be airtight. And we compiled it with the sealing system of Proclima that tapes all the seams. So you can see all the penetrations that happened there that all got detailed. The next step was, after that was all done and taped and prepared, was to install the insulation. The insulation's a 2.5 inch insulation tongue and groove shiplap that then all the seams got taped for as an extra vapor barrier and an extra layer of protection. And then the dry ply went down. The dry ply went down as the subfloor for all the framing that you're standing on top of. Right here, I'm showing the guys how to add extra sealant into each one of the holes that are drilled into the floor so that we didn't have any air or water penetrations. And that was a lot of hard work to figure out. It was a good teamwork. We did mock-ups, we back and forth. It came out great together. It's not a conventional detail, but the teamwork was great that we worked upon. And go ahead. You got to hop though.
If they're gonna hear me, but we like to keep the cellar slab here for code reasons. And that ultimately is the reason why this detail was so difficult, because we have never done this before. Most of our passive houses, we take the cellar slab out, and then we insulate and air seal basically with the stego underneath the slab. We couldn't do that here, so we're limited on our ceiling height as well. Although this is pretty good ceiling height for a cellar, for it to be nice usable space. We were, of course, trying to get every inch that we could. So the challenge was, how do we maximize our ceiling height, minimize the floor assembly, air seal it, insulate, and make it durable and airtight at the end of the day. So we still haven't actually selected our finished floor, but what you're seeing is the plywood that is basically serving as both the subfloor and the airtightness membrane. Well, sorry.
Okay, great. So just continuing on downstairs, this is the membrane, this is the layer. And then we went with the different sealing system than the manufacturer suggested. We have a sealant caulk in between, and then a tape layer, all sticking with the airtightness layer system. So sticking with the Proclima system from subgrade up the walls all the way to the roof. It helps for compliance. It helps for just knowing that the products are going to work together, as opposed to going from one manufacturer to the other. And it's a European airtightness system that's been proven over 25, 25 years in Europe. So it has a little extra oomph behind it of sticking to the airtightness layer. So besides from the basement, and as in good show and tell process, just these are the membrane from down below. There's a little bit of green sealant that might be a little wet, so just watch your hands or delicate clothes. As good as all good preschool teachers should wear your schmucks. And if I could then just talk about the next layer moving up the building is the Viscon. So the Viscon is a fluid applied air barrier. The applied air barrier goes on the wall. But there was a decent amount of prep work that needed to happen. So the brick needed to be clean and brought down and repaired. We did, the R.S. Sutton team had the walls parge coated, which means skim coated with a lime mortar mix that the mason came in and did. And because it's a certified passive house project, we wanted to make sure that we were really going for that airtightness level. So with the parge coating helped us to not have to use as much material as the airtightness installers. So you can see Timmy and Mike here installing it on the wall with the spray machine. The spray machine's on the 3rd floor, so when we get up there, we can show you what the spray machine looks on. But this is 2 to 3 coats of the material on the wall. It goes on at 8 wet mills, and it's the process of installing it is really important to make sure it's consistent. The walls, masonry walls themselves, are never perfect and clean and dry, so a little extra material always goes in. So our process is 1 coat, expose all the holes, and then do a brush coat, touch-up coat, and then do a finish coat that goes on top of it, and then go back and check again. And then as they're making penetrations and fastening through the wall, we're making those repairs as well. So this air barrier is on all 4 sides of the exterior wall and everywhere. Because this is it's the shared wall of the building is the party wall. It tends to be our largest surface area, and it has the most amount of penetrations. If we move up to the joists, which you can see up here or up to the top there, each individual joist needed to be scraped, sanded, and made smooth, and then filled with either mortar or foam, the gaps, and then they were coated with the air barrier material. So when you count up these joists that go through, it winds up to being a decent amount of work. On the other side, wherever they did the actual new joist or new penetration, either an LVL or steel, we did a process of pocketing that goes inside, which isn't really shown well here. But if you could imagine the kids. So the parge coat goes on very thin. It's about a 1/4 inch or so, maybe 1/8 of an inch. It's just a smoothing or leveling out the masonry. In order for it to be considered an air tightness layer, like in Europe, it would need to be a triple coat plaster. So it would be brown coat, scratch coat, finish coat. Comes out to be 3/4 of an inch or an inch of material. From a systems and trust point of view, trying to deliver performance, we trust the fluid applied air barrier a little more. And our skill set isn't slinging mud and making walls with the plaster. It can be done. Like if the existing plaster was in good shape, we could rely on it as a decent layer. But most times over the past 150 years, that plaster tends to be in rough shape, and then you have to manage it at the through floor connection anyway because it wasn't at the joists. So it delaminates, it breaks off. It's a tricky detail.
And then can you explain why you floor plate and then that as well?
So because we spent so much time in detail on sealing the joists, we wanted to utilize that and not have to redo it. So to value engineer out that work, we decided that because this is in shaft wall that's exposed to the outside, we said the insulation layer needs to be protected by the air barrier, and we wanted to run it down, up, over, and around. So insulation works very well when it's sealed on 6 sides. That's how it performs. So instead of having to detail it through the floor and tape every single joist, again, sealing it, our method now is going to be to insulate that with a rock wool and then maybe a rock wool face with Intello, and then spray those joints as well with to seal them from a vapor point of view. But our main air barrier seal on those joists is the Viscon.
Yeah, and just and just one clarifying fact that typically the buildings we work in, that we have party walls, shared party walls on the sides. We did not have that advantage here. We have a really large air shaft on where the two buildings meet. We have two each, and this building has its own walls, so we don't have party walls at all. And on this side we have an air shaft where the two buildings meet. So it's basically a lot more exterior wall here than what we typically deal with in a row house. So, and that's part of why we really have to be careful where the joists are meeting the walls on the sides. So.
Arrow barrier could do it, but it would be late in the game, kind of. So we'd wait until the end when nothing was exposed to then try and fill it with the aerosolized adhesive to then try and plug the holes. And these building typologies are very tough to seal, so it's better to try and do it with the craftsmanship when you can get it. And if you need the aeroseal at the end to get you over that last milestone, use it there. It's kind of like if you're touching it, do the best you can with what you have and when you have it. Aeroseal is a great product when you need it for retrofits that you're not fully gutting, but if we're gutting it and you have to touch it and you have to repair it, repoint it, you might, in my opinion, just might as well just truly coat it. Just good details to talk about while we're standing in it. So some of you are standing in what's going to be the garage area, and this area is going to be outside of the envelope. So connected to the outdoors through the garage door, and it'll be fully thermally broken with the insulation that's below the track here. So if you can see, you can't really see it all that well, but there's insulation under the track, and there'll be another layer of insulation that goes down. There'll be another layer of insulation, and then a topping slab that goes on top of that. And then this wall will get insulation inside as the insulation layer, and we'll tape the seams of that or seal the seams of that. So this will be totally sealed off and thermal broken.
And that's why we have a step here.
Cool. What, you guys want to go upstairs? Anyone in the crowd have any questions? So it's an interesting spot in the house because the apparatus floor on the bottom is kind of like the work zone, the transport area. This is the first area that's going to get all of the passive house treatments, the second floor of the building. So it got the Viscon on the walls, complete, front, back, rear, and sides. Then it got framed by the framing that's up here. The framing's furred off the wall by an inch. So it's a 4.5 inch cavity at a minimum, maybe it could be 5 inches. And then it gets the air barrier gets installed on the wall. It's continuous top to bottom in one sheet, not a lot of seams. Then the next step would be to tape the seams. As you go across here, tape all the seams, tape the bottom, and tape the top so that it's 100% sealed. And then the next step of the process, in order to ensure that when you insulate the wall, it stays in the wall, are these furring strips. The furring strips on the wall keep the air barrier from bowing out. This is like a ripstop fabric that when you blow the insulation in the cellulose with the high pressure machine, it tends to bow. And then this counter batting or the furring strip keeps it at bay. And then this next layer is called the service cavity or the horizontal layer. And that just gives you the ability to run your electric wire that goes through it throughout the wall without having to penetrate the air barrier every time you make a picture hole or decoration or so. So the process we used to install it was developed over time. We started out manually with a manual staple gun, some sole wrists, right? We then upgraded to battery operated when batteries work, and that's pretty effective. And then we've upped our game with the semi-automatic stapler. So I'm just a little, for those construction nerds out there, a little trick to the trade. The tricky detail of this whole project isn't just putting the membrane on the wall, it's managing the corners. So in the corner here, this air barrier comes in, goes down, and it goes the through floor detail. So the Intello goes down, under, and over and back underneath it. There's a stud here that goes across. And because of the flexible nature of the fabric, it has the ability to go down, under, over, and back down. So it makes it one monolithic air barrier on the whole front wall. This air barrier here does 90, a decent part of the air sealing for the outside of the building, because this is the most severely exposed wall, the fronts and the rears. So this tricky detail is what makes passive house level possible, and it's important to get it done. And then in the corners, making sure that it's sealed and it's done and it doesn't get ripped. It's a little bit of an art and a science. The art is that doing the inside folds and taping it and making sure it doesn't damage, and the science is understanding how is there going to be condensation and is there going to be air leaks. So it's a fun process creatively, but as much as we try and repeat this, every one of them is different. So it takes a little bit of training and a little bit of understanding to know what's airtight and what's not airtight. And we've over the past 5 or 6 projects, we've gotten pretty good at it. Like this floor is going to be different than that floor. There's going to be different penetrations everywhere. But once you get airtightness, it's kind of like blending in on what it is. Other tricks of the trade and the tools, wipes, making sure that whatever you're taping to is clean. When you put the dirt and dust on construction sites, everything is dirty and dusty. So these are wipes with alcohol. They're like commercial industrial wipes, and then you wipe it until it's clean, and then it's dry. The alcohol flashes off quick, and then you're able to tape it. And then taping wise, everything needs to be pressed or rolled. So it's pressurized acrylic adhesive, which really makes this stuff stick, and it needs to be pressurized in order to actually stick permanently. So it's either a press fix or a roller. Back of the hand kind of like delaminates over time. So the next step of this wall is kind of frame the front wall, prepare the rough opening for the window. You can see that the window here is kind of prepared for the rough opening, for the windows to be coming in. The Viscon goes into the rough opening around the masonry and out to the front. That gives us a nice clean layer to tape to from the outside air, or the wind tight layer to seal to. And then the foam insulation is what makes this window perform a lot better. It thermally breaks the window on the install. Our next level is then the Sill Seal and getting that through. And then there'll be framing, then the Intello will come up. And once all the Intello is complete, then we'll bring our insulation machine here and we're going to blow cellulose. Cellulose is a great product. It's where I started my career in weatherization, working in low-income houses, blowing cellulose. It's a great product. It's hydroscopic in that it can absorb moisture, give off. It's a second generation recycled product. It has a lot of benefits to it. Newspapers, cardboard, whatever we're making it out of. I have a lot of trust in it. So we've also started blowing rock wool too for higher R values too. So fire resistant construction.
Hey, Kevin, can you hear me?
I can hear you, but Michael's asking a question.
Okay,
Exactly.
good. It's great.
The joist on the exterior side of the Intello, about condensation. The very smart people at Building Type and Baxt Ingui have really analyzed these details over time with either Roofy or Flixo, and with the manufacturer's support, they've analyzed the risk of condensation rotting out those joists. The beauty of the Intello is that no moisture really gets trapped in the assembly, so rot isn't going to happen. The Intello is vapor intelligent and that it'll open and close based on the moisture content in the wall. And stopping hot, moist air from getting in those cavities is 90% of the game is over from starting risk. When you have hot, moist air that gets into areas and then condenses, that's where your problems come in. A joist that's dried out and been in place for a while, I'm not really too concerned about it rotting away, especially since that it's not trapped with moisture. If we were doing a vapor barrier here and sealing it in on 2 sides, then I'd be a little more concerned about the joist deteriorating over time. But we get that information from construction demolition and like things that have failed over the years, and then also the feedback from the WUFI models and the hydrothermal analysis.
And then I think somebody maybe asked a question earlier, why are we using metal studs in certain areas and why are we using wood studs. And we are using the wood studs on the exterior walls because it is, it thermally performs better, and all the metal studs would be a thermal bridge. So we avoid it anywhere where we have an exposed wall, but we did use the metal everywhere else because it was easier to get and less expensive right now. So we actually, that was part of our value engineering process, was to make sure that we could use metal anywhere that we could. But we kept the wood on the exterior walls. And then in the cellar too, we use the metal studs just because it is a more likely place to have moisture issues. So we stuck with the metal in the cellar. So.
And then Kevin, one person just asked the question about using mineral wool and rolling it just to make sure that you've got it covered. And have you thought about using that instead?
So the question is,
the bat.
we used bat insulation before. We use bat insulation, but bat insulation is like a really unfair test in that it needs to be installed perfectly. If you get 10% errors or 5% errors, that A install, B install, and C install, you get a 30% reduction in your R value. So user error reduces the R value of that install by 30%. Plus these wall assemblies are not very bat friendly. And I'll show you that in that we have a 16 on center cavity here, 4 inches deep with true LSLs. And then you have an inch and a half gap here. So from the manufacturers, and in limited production these days because of the demand, you're going to have to do this in 2 layers. So you would have to do a inch and a half layer and then feed it all behind the studs and go across it and then do another 4-inch layer. And then any gaps, cracks, compressions decrease the R value. With the pneumatic install, you're relying on the machine to install the insulation as perfectly as possible, as opposed to the manpower. And then, like, it's nozzle man integrity. When it comes to blowing cellulose, it's blowing throughout the whole cavity. The nozzle goes into those areas. Lower.
Higher.
How about now? Better?
Yes.
Can you hear me now?
Yes.
Okay.
Very nice.
All right. I'll speak from a normal tone of voice now as well. So cellulose being blown in these wall types and behind the membrane, you can touch and feel everywhere that you need to go and that you need to be. So I can touch this wall from top to bottom and it feels like a firm mattress. I have confidence that it's dense packed. As a quality control measure for our company, and just good pride, is that we measure the density every 2,000 square feet. So we cut a hole, we do a core sample, we take out our scale and we measure it to make sure that it's above 3.5 pounds per cubic foot, so that it's not going to settle over time. Our machine is calibrated almost like once every 6 months. We check the pressure. We do regular maintenance. It's kind of like a sports car for us, So that's our preferred method on the bats. And then from a cost point of view, cellulose is a pretty affordable product, and the process of installing it is pretty straightforward with the right machinery. You can't just go to Home Depot and rent a machine and expect a dense pack. You need a good machine. So I hope that answered the question.
Hey, Kev, I know you were way early on the windows, but can you describe kind of what's going on there? Because I think that you can see the brick return, which is nice, and the insulation.
All right, I'll give it a shot.
And Ed's on too, so Ed, feel free to chime in anytime you want. I'm glad you're here. Ed May. Well, he's not here, but he's on the Zoom.
Ed's in Italy. I'm very jealous.
You're in Italy?
Ciao. Buonanotte. Okay, so the window is going to sit here. It's going to sit recessed right here. The window is going to sit right here. It's going to be a fat frame going across. This is the window itself. It's going to be maybe a half inch across there. It's a triple pane window, and that is going to go across there. And then there's going to be an air seal that comes across here. There's going to be an air seal that comes across here all the way over and then marries to the face of here. And then we're going to fill this gap with spray foam. So the window itself is going to be thermally broken between the rigid foam and then the foam that we spray in place. The window is I believe a Zola wood frame simulated double hung window, triple pane. It's a wood frame, so there isn't as much thermal bridge as there are, and the window works and it's been analyzed. Our job on the site as the construction professionals is to just manage the details, make sure that we're wrapping the frame with insulation, so that we take an R7 window and it installs as an R6. We don't take an R7 window, install it poorly and make it into an R3 window. So, great trick you learned in the Passive House tradesperson class, right? So, a calculation. We keep this dog and pony show and go. We can go upstairs and talk a little bit about the process of spraying the Viscon and the tricks and tools that we use there, unless there are more questions. Anyone in the crowd have a question? Cool. Yeah, good. The third floor you will see. So they become arched windows. Taping and air sealing those it's once again, it's like an art and a science. This building was the challenge is just going honestly is going to be the weight of the windows. Just getting them up. Normally we deal with smaller windows, and then they're being like a fixed window and then a sash. Hopefully we can take the sash out and then only lift the lift the heavy parts, but I think we're gonna work get that done. It's the challenge is the size of the windows, the placement, and then like if you guys could see these windows, the rough opening of the window before these guys all fixed it. What? Repeat the question. Was there any major challenges for this masonry building? And the answer is there are many masonry challenges, and the main one was getting this smooth, clean and dry to accept the window. When we demolish these buildings, you see severe deterioration at the sills, the jambs and the heads. The brick is almost like falling apart from getting wet and dry and leaking over the time. So in order to get these back to where they originally were, take some love and some craftsmanship. And then upstairs, there's the arch windows.
Another question came up: how much shim space do you leave for the windows? I mean, not a lot is typically the answer, but definitely tighter than the contractors ever want them to be, I think.
You can look at this window and see that they've already prepared for shimming and to know how to get the window. All right. So I'll keep this wonderful.
And then we'll use my
Aftershock.
phone as a secondary mic. We're good.
Got ya. So just to repeat what I said during the possible audio outage, the blocking is for fastening, and most likely we're relying on the strapping system or the clips to fasten the window. The shims are not going to stay there permanently or be like the main support of the window. It's the screws and the strapping system that holds the window in place. The shimming of the window is what we do to get it where it needs to be plumb level and square. And then after we foam and seal the window, it may shock some people, but you only hard shim top and bottom. You don't leave it shimmed in 7 different places, because if the window wants to move, the window's going to move, and you want the window to be flexible in the rough opening, not firm and hard, because once it's firm and it's hard, what gives is either the glass, the gaskets, or the hardware. So buildings move. We don't think they do, but sometimes they do. But we're eliminating the stress of the wind, the airtightness, and that's kind of the area. How are we on time? Okay. So we'll go up to the next floor and talk about the application process of Viscon.
So I'm going to turn my camera and mic on just so you guys can see what everybody's up to. It's a great job site. And there you go. The way it's set up is they've got a really well-built scaffold, nicely wrapped so the neighbors can't see in. It's allowed this whole rear of the building to stay open during construction while they're installing the steel frame, and we're using it to get around the job site as well. It's a really, really well-run job site. You can also start to see how much of the original joists we're using. We saved them all. And this was at a time when you couldn't get joists. So even though these came out, they went right back in. So it's good stuff. You can also start to see a little bit of the floppy bit left over there where Kevin's got that installed before the wall goes up. Just small items, by the way. You can also see how organized the contractor is. Gantt chart, always up, always reviewed at every meeting. Well, not every meeting, but most meetings. So anyway, with that, I'll turn my camera off and we can go back to the regular programming.
I think it might be good to just show the arch windows since we were just talking about it to keep on topic. Just watch the. Yeah. So just to reiterate the challenges of a masonry building here, we had these windows didn't originally look like this. They were square at the top. They filled them in at some point in time through the years. And in order to replicate the historic nature of the property, they recreated the arched openings that go in there. So the window is going to be arched. It's going to be sit inside there. The brick mold and the return is going to need to be there. And that's a challenge in itself from a carpentry standpoint, measuring the windows, making sure they fit, kind of like that challenge there, which has been done before by the team. And, but there's a little bit of challenge there, air sealing wise, insulation, and then just square and rough opening point of view. So that's the Pat.
Can I help?
Yeah. This is all touched up.
Everything up here.
Here, you want to come to us?
Sure. Am I already off mute?
Yeah.
So these windows originally came across, there was a header right here that came across. And the arch existed from on the exterior face, but not on the interior. So you can see these 3 new pieces of steel, these 3 lintels that we put at each opening. This is new brick. And this was all supported as we went. So this is actually, talking about surveying each opening. We're actually gonna, I don't know if we talked to you about this yet, but at this level, we have to push, we'd have this gap here if we keep the window at this, so we're gonna install them probably further out to make this connection. I think you and Luke have already talked about that, right? But it's like, right.
This building is
It's,
atypical.
yep, that we have the 2, so we're
Yeah.
right. So we're gonna come back out to it anyways, but that'll affect probably the floor below, yeah, but
Windows to be safe, plain.
right. Right. And then these will probably get, I don't know if we'll skim these again or if these are, we'll probably do another coat over here before we do our Viscon at this whole operation, but it's I'm sorry, like the parch coat, yeah. But it's all, each of these windows has taken a lot of, masonry work to get it up to speed, to get ready for you to do your thing.
Just to piggyback on that, this is the parch coat that went on. So this is a gray lime mortar slurry mix that got applied with a mason's brush or a roller and hand troweled just to fill in all the gaps and the cracks that were there. Because what we've learned is when you do the spray applied air barrier, it's all about the making sure that it's one monolithic continuous layer. It takes a lot of love, a lot of attention, and this takes the substrate being poor or better takes the stress off of us. So if we can circle around there and go to the spray machine, and we'll show you guys how we, the process we use to spray. Follow Tim and Mike. No, we don't. It's too much to clean. Yeah.
While they go there, again, I'll point out how many of the original joists were taken out and reused. So again, it's really important when we're working in these old buildings not to throw away things that do not need to be thrown away. And these are, they're perfect and they're great. So they went on brand new hangers. They're all set up well. And again, the beauty of working with great scaffolding. We're fully open to the elements, but they're never coming in. The neighbors aren't getting dust. So it's just a really great job site. And with that, I believe Kevin's just about ready and I'll jump off.
All right, so applying an air barrier. Can you guys hear me? Give me a thumbs up. Excellent. Applying an air barrier on the wall is all about getting one monolithic air barrier on the wall at the right mill thickness, which is measured with a wet mill thickness gauge, and then filling in all the pinholes, gaps, cracks, and everything that's there. The best process that we know how to do that on masonry is to spray it with a consistent pattern, to lay it on the wall, and then to go back and back roll it with the roller. So it's like kind of like a three-man operation. One is the spray guy, the nozzle guy, then we have the control guy managing the machine and the material, and then there's the backup guy, which is doing all the other activities of wrangling the hose and back rolling the material on the wall. We've done some technological advancements over the past year or so. We have a power roller, which then takes the material from the sprayer, injects it into the tube, and then it comes out of the pores inside of, there's little pores that are inside this roller, and then it gets put into it and you're applying it on the wall like that. That's called power rolling. And then the other one that we haven't quite mastered yet, but have the ability to, is called spray rolling. Well, there'd be a spray nozzle here that sprays above it, that comes down, and then so you would start down here, spray it on the wall, and then you'd be rolling it in place, trying to manage the efficiency. And the latest thing that helped us out with doing all the joists is the Arasana Viscon application tool, which is I'm able to detail out all the joists with the material coming from a sausage and spray it around each one of the joists rather than trying to have to detail it by hand. So I apply it on the wall pneumatically with an air compressor and spray it on the wall. It also helps to do touch-ups too. So I'm just taking sausages, throwing them in, spraying it across. It's a cool tool. It has a lot of benefits. It's about the process more than anything else. And then when you have tools, smart tools in smart people's hands makes things go very efficiently. And when you're shooting for excellence, you need every advantage that you can get. And then the teamwork aspect of it is really important too, because anyone that sees a mistake is or like a gap or crack should be known, like, hey, let's find it together, mark it for us, like let's put it on the wall. So the application process is it's fun, it's messy. So Amy was asking about the sealant that we're using. So sticking with the Proclima system, we're using the Viscon, we're using the Proclima tapes and the membrane. There's also a sealant, I believe it's Archon HF. It's this green sealant from Proclima, is how I best know it. And any of the penetrations that get drilled through the wall misses, it just gets put with that, and you're sticking within the one manufacturer system, as opposed to going to say like another manufacturer's caulk that may not really work with this sealant. So just kind of the sticking with the system of airtightness. So it is very nice to know that you have some support from the supplier regionally, and that if there's a product issue, they'll troubleshoot it. So any open hole that's a miss or a drill needs to be filled. Anything that has a bolt in it, like a threaded rod that's epoxied, we're gonna use the nature of the Viscon to seal that. So it's kind of like having multiple tricks in the toolbox to go across. One of the last cool things on the project.
Quick question on that though. Application temperature, cure time. Can you go through that if you don't mind?
Application temperature is above freezing, so it can't go below freezing. The product itself can't freeze. It's a water-based product. If it freezes, it separates. So general rule of thumb is, I think, above 40 degrees. It's above 40 degrees in here. We didn't apply it really in the dead of winter, but if we do, we'll have to, this building will be heated and tempered as we go along.
Sorry, you need to say that again.
Oh, sorry. The Kev, you were saying about the question was about climate temperature control, right? So the next step now at the back of the building here, we have this 20-foot by 30-foot masonry opening now. Well, we've had it there now for a while, but we got to close it. So the framing's going in, and we're gonna put temporary, like 2x3 structure with 4 mil plastic on each side, so it's kind of like an insulated
We'll get it.
filler.
Temporary. Windows.
Right. So right. So we're really gonna. It'll be something like this, but with 4 mil plastic on both sides, and it's going to be at every opening, and it's going to be like a big. It's not going to be thrown up there. It's going to be a pretty serious thing because the windows are such a long lead time, and we got to keep this party going.
When we can sequence things on projects, if we could get the Intello up and not cut out the windows, it makes things a little easier. So like say the front wall, if we just put up the Intello, didn't cut the openings and tape the seams, it'll keep the project tighter, cleaner, and dust free. And then I can run a blow a door earlier on, check all my penetrations while they're out and they're open, double check them with a smoke test and troubleshoot anything I may have. And then that makes it easier, and you just leave it in place. Anything you're putting up, like it's, if we can do it smart and cost effective and teamwork wise, like use.
Before temperature,
No. Yeah. Yep. You can't let wind driven take out all the heat that's going in. Just one thing to mention about the rear of the building is that we're doing a rock wool based EIFS system. Fire resistant in an old firehouse on the rear of a building. Just seemed to be a good fit. Neighbors trash our modern dynamic issue of buildings, because it'll be sprinklered, is burning the building down from the outside, not the inside. So having a rock wool fire resistant outside, to me and to the design team and to owners, made a lot of sense. The other part that's beautiful about this is that it's vapor open, that it can dry from the outside, from the inside to the outside through the rock wool. We went through a few manufacturers. We're still going through the process of selecting, but Roxel and Master Seal, and have a product that we're going to be looking at. This is the Stowe product. So this is their sample, very nice sample, but we'll see which one we decide on and we go through. But for me, team wise, it's the same thing. It's a fluid applied air barrier, and it's insulation adhered to the building. The only thing that changes is the amount of mesh that goes on the outside and the finish. So it's cool. It's innovative. Be tricky at some of the windows, like tying in the lift and slide windows and the flashings, but it's a happy challenge.
So one of the questions I want to ask Tim while you're here is Pat. So close. Tim.
I answered all my brother.
And Tim's on. He can answer it. You might as well answer it. Anyway, the question is, it's your first passive building. It's a big project. You seemed confident when we were bidding it. You still seem pretty confident. Do you want to talk to, especially people who are doing this for the first time, any thoughts? And it's going so well, so I figured you'd be a good person to talk about it. Or Tim can answer.
What's up, Tim? I think the key on this project, it's been mentioned already a few times by a few different people, but the team that we have together here, it's not making it easy, but it's making it easy. Like there's so much support from Amy and Joey, and then from Kevin on site. And it made, like, an example would be when we how we put all our heads together to fasten the plywood in the cellar. And we were trying to get the caulk, or it was like the ceiling. Yeah. We tried to get that. We had to get it all the way down to the dimple mat. So it was this like MacGyvered solution with me and Kevin and the two guys working, and Luke, the two guys working on the floor, that we got this like extra nozzle that you had kicking around, and we kind of duct taped it to the applicator and made it work, and it's getting all the subs to buy into it. And actually like see what we're like, not just saying do it like this, but say we have to do it like this, and this is the reason why we have to do it like this. And so far it's been working. People are like, the subs we're working with are into it, and everyone's doing the right thing. And I think like the more we progress, like you now have your sample that we all just looked at. That'll be great to show. It's one thing when you try to describe to someone, we're going to do it like this, and then you have your service cavity. But it's another thing when you say, you see what we're doing here, and we're doing that all along, and we're still going to make that, our little office in the back, which will help too. You can describe how we're gonna do it. I know you like talking about that, the office with the pH.
The goal is to do a first run sample on all the assemblies.
And to do the first run sample on the assemblies, install 3 walls and a door connected to an actual wall, window, or door, and then be able to test it to know if all your products and critical details are coming together. And then it's a nice place to have a meeting or a phone call, or to get out of the cold, to keep my material from freezing, whatever it might be. But to then go through the process of putting up a wall and doing it as you are on this site, furring strip, counterbatting, and then going through the process between layout, finish, and insulation, and then where testing could be. So the goal is to have an office that is the first run mock-up, so that when we say they get a new carpenter, and it's like, all right, it needs to be done like this. You take it to them, you say, step 1, 2, 3, and 4. And just to prove like it's not only just what we're on paper or doing, it's actually there. You can look at it, and collectively, it's amazing on how somebody who doesn't know anything about Passive House can have an innovative idea that makes things a lot easier. So it's creating that teamwork and buy-in. Nobody really likes to be told what to do. They like to be a part of a team that has impact. Like those guys doing the floor, they got into it. Once they understand what they were doing it and why, like they got it, but when they were just told, put the gray stuff on the screws, they were putting the gray stuff on the screws, but they needed to get the gray stuff down at the mat and then into the screws. So that's like the reasons why we do the things that we do. Not everyone needs to be a building science expert, but they need to know the unintended consequences of doing something, unmute.
All right, are we good? Okay, we had a surprise DOB inspection before this, and Luke texted me, DOB's here. I'm like, oh great, it's gonna be the whole all the crowd here and DOB walking through. And Luke got to talking with them about all our pictures are up on the first floor. So the guy's kind of like, oh, what's this? So Luke goes right into, oh, this is the dimple mat, and this doesn't describe the process. And he was even like, oh, all right, cool, man. Yeah, so even it is a thing that's interesting, and that people, including DOB inspectors, are like, all right, cool. And he was on his way. He checked out our details and kept it moving. So I don't know. It's cool. It's like everyone's in on it. Everyone's bought in. So
it's a different culture. Like I remember
going on my first Passive House open day tours to projects like Jane's and to other ones that Ken was involved early 8 years ago, and it was like, wow, these guys are doing really cool stuff. I want to do this, and they were leading by those examples and then sharing those lessons. This community that we have in Passive House are an amazing group of people that just share. They welcome you into the project. They tell you all they know. They tell you how they screwed up, how they would do it differently. That doesn't happen in other industries. Like they keep their secrets to themselves and they don't share. But by opening the doors and welcoming into Passive House, people experience it, they learn from it, and they share. And we've just been growing in the New York City community. It's been an honor to work with such great people on great projects, to drive around the city, and then to know the performance of them too, to know that they have really good indoor air quality, especially in a crazy time we live in now. And then to have a building that could last if power goes out or whatever it might be, is just, I think, reassuring. So it's craftsmanship, it's pride. And, working with you guys, it's smiling dudes that take good pride in their work. And I'm proud to be on the team, so it's good work. It's good stuff. That's my speech. I'm leaving. All right, team, you ready? All right, Zach, do you have any questions from the gallery? Does anyone have any questions?
We just had a good question from Bill Dinklage, but I think Ed May answered it, so not at this moment.
All right, last thing I always like to leave off with is every high performance project has a high performance owner, and it's great to have people that believe in our mission and trust us to accomplish their mission. And deliver something, that's great. So it's appreciated. Cool. Good to have Ed on.
Yeah, I just took myself off mute. So it looks like Ed answered all the questions on the chat. If anybody has anything before we sign off, put them in the chat right now. Otherwise, I think we're done, right, Zach?
I think
And
we're
does
good.
anybody have
Yeah.
any questions?
Thank you, Ed.
And thanks, Ed, for
Yeah.
answering so many questions.
Yeah, definitely. Oh, we've got
Yeah,
another
we
one.
got one.
Why use mineral wool EFIS versus rain screen? Just the cost?
That's a design question.
What was the question?
Why did we go with rock wool EFIS as opposed to rain screen?
Oh,
Just make sure Matt is active. You're good.
okay. So we, to be honest, we didn't really look too far into a rain screen system. This is a masonry building that, I don't know, we're not really trying to, and especially, well, first of all, this is only for the back that we're doing the rock wool EFIS system. In the front, we're leaving the brick exposed. As Mike said earlier, we're treating it like a landmark building. So we're repointing the facade and we're restoring it as it would have looked back in the day. So that really we're just talking about the back and the side walls and that are exposed in the back. And we don't really want to spend a ton of money there because we don't have much of a backyard, and that we really just have like a 5 feet space in the back, and then we have a couple of roof decks. So you're really not going to be experiencing the back, although we wanted the facade to look good. But in the end, we just feel like a white, clean surface. We've got these really great big arched openings that are kind of echoing the firehouse classic design, and it's really all about those openings. And so we really just wanted the facade to kind of go into the background. And so then it's a matter of, okay, how many inches of insulation do we need? What's the right product? What's the right system? And how do we make it work with our window detail? And that's exactly where we are right now in the process. So that's the background.
That's it.
I think. All right. Well, thank you everyone for joining us today, and for your interest, and thank you, Ken, for setting it up, and thank you, Zach, for organizing.
All right. Thanks, everybody. Thank you to the project team for making this happen and for navigating the technical challenges that are inherent in a live tour on Zoom of a project. And thanks all for your patience with that as well. It was fantastic, and happy Friday. Have a great weekend. I hope you enjoy International Passive House Days, and we'll see you next week. Take care.